Okay, good morning, dear students. This morning, we shall take up the topics Cosets, Lagrange Theorem, uh, Quotient group modulo H, normal subgroup, Homomorphism, Isomorphism, and rings. Okay, to complete or to um, cover up all the remaining topics in abstract algebra. Okay, so we begin with the concept of, although I have listed cosets in my title slide, or should I say the first slide, we will begin with the Lagrange Theorem because we shall take off from subgroups here, okay, and look into order of the group and its subgroup. Okay, so the Lagrange Theorem states a relationship between the order of a group and its subgroup. The theorem says if H is a subgroup of G, if H is a subgroup of G, then the order of the subgroup H divides the order of the group G. And by order, we mean number of elements. Okay? Number of elements in the group and number of elements in the subgroup. So, for example, okay, taking for or as an example, z sub 6, the additive group z sub 6 or integers modulo 6, there are 6 elements, right? Okay, and the subgroups that could be generated from here are, okay, 2, 4, 0, that which is generated by 2, and whose order is 1, 2, 3, the order is 3. And 3 divides 6. The order of the group is 6. 1, 2, 3, 4, 5, 6. So when we speak of order, please do not forget that we mean the number of elements. Okay, another subgroup of Z sub 6 is the group, okay, subgroup generated by the element 3, consisting of 3, 0. Okay, 3, 0. Okay, and there are how many elements here? The order of H sub 2, the second subgroup is 2, and 2 divides 6. So do not expect for a subgroup of Z sub 6 having an order of 4, okay? Because 4 does not divide 6. And do not also expect for a subgroup with an order of 5 because 5 does not divide 6. So the Lagrange theorem then allows us to predict, okay, the possible subgroups of a given, the order rather, of the possible subgroups of a given group. Okay, now for the cyclic group, okay, last time we discussed also a cyclic group. When is it cyclic? If there is an element A which could generate all the elements of G. A raised to 1, A raised to second, A raised to, okay, the third, and so on and so forth until A raised to n, and that gives the identity element, okay? So we consider the cyclic group generated by A, okay, where, okay, the elements are A squared, A cubed, until A raised to n, and that gives the identity element. Says here, if the order of G, if the order of the group is prime, then all elements of G except the identity element are generators. Okay, I think we made mention of that last time already. When is an element a generator and when is it not a generator? Particularly for Z sub M. Okay, set of integers modulo M, additive group. Okay, so are there questions on the Lagrange theorem? Just as simple as that. Okay, it talks about order of the subgroup and order of the group. Okay, next, the left and the right cosets. What do we mean by left and right cosets? Okay, by definition, if H is a subgroup of G and A is an arbitrary element of G, then the set of all elements of the form HA, since H is, okay, H is on the right, okay, H is on the right of A, then it is a right coset. Okay, HA, where H is an element of H, is called the right coset of H in G. Okay? The opposite, when we swap their places, that gives the left coset. A times H, okay? A times H, where A is an element of G, and H here is an element of H. Okay, what do we mean by this? Let's look at an example. Okay, find the left and the right cosets of H equal to 0, 3, 6 in Z sub 12. Okay, so going back to the definition, take note that H is a subgroup of the group G. Okay, so is this a subset of Z sub 12? Okay, 0, 3, 6. Okay, find the left and the right cosets of H equal to, okay, 0, 3, 6 in Z sub 12. Is this a subgroup? Let me check. Okay, 3 plus, we lack 1. Okay, let me check. This is supposed to be 0, 3, 6, and 9. Okay, 0, 3, 6, and 9. That one generated by the element 3. Sulatan na lang natin. Okay, so and that means 3 and then plus 3 is 6, plus 3 is 9, and plus 3 is 12. However, 12 modulo 12 is, okay, 12 modulo 12 is 0. So, this is supposed to be 0, na-erase, hindi ko na-include, 0, 3, 6, and 9. Okay? So, our H here is the subgroup whose elements are 0, 3, 6, and 9. And the group G, okay, is your Z sub 12, set of integers modulo 12. So 0, 1, until which number? 4, 5, 6, 7, 8, 9, 10, until 11. Okay, what are we going to find? The left and the right cosets. So by definition, the right coset, look, we are talking of coset, not necessarily group. Okay, right coset is formed by the elements HA. Okay, where HA is equal to the set of all product of HA, where H is an element of H and A is an element of G. Okay, so how will that look like? Let's, wala. Okay, we insert an empty. Let me check first. Ito siya. Bumalik tayo dito. Okay, the right and the left cosets of. Okay. So, we pick out an element of G. Okay. So, let's begin with H times 1. That would be, take note that our operation here is addition. We are talking about additive group Z sub 12. Okay, the set of integers modulo 12 with respect to the operation, okay, addition. So, if we have 1, H 0, we begin with 0. Look, we consider, okay, where did we get 0? 0 is any arbitrary element. You can begin with any of these elements from G, but I prefer 0, okay, 0. So 0, then that will not do anything, or should I say that will not change the values of H, right? So it goes back to H. So it will still give you 0, okay, 3, 6, and 9. What do we mean by this? Add 0. Add 0. Where did we get 0? 0 came from G. Okay, 0 came from G. We add 0 to each of the elements of H to get the coset. Okay, so 0 plus 0, 3 plus 0, 6 plus 0, 9 plus 0, it gives back H. Okay, which is in fact H. So I will write here H. Okay, H1, so just the same, all elements of H added to 1. 0 plus 1, 3 plus 1, 6 plus 1, and so on and so forth. So that will give you what? 1. Okay, adding 1, that's the same thing as adding 1 to every element of H. Okay, adding 1 to every element of H, giving 1, 4, 7, and 10. Okay? Plus 1. 1, 4, 7, and 10. Next, H2, what will this be? Okay, H2 will be, okay, add 2 to every element of H. Add 2 to every element of H. So you'll have 2, okay, 5, 8, 11. Okay, now we proceed. H3, this is not a subscript. Sorry, this is not subscript. H2. Okay, next, H3. What will H3 be? Okay, add 3 to every element of H. Where did we get 3 from here? Okay, 3, 6, okay, 3, 6, 9, and 12. However, 12 modulo 12 is 0. Take note that this gives us back to the subgroup H. Yes? What happens if we continue? Okay. If we continue H4, what will this be? Okay, so if we add again 4 and then plus 3, 3 plus 4 is 7, and then 6 plus 4 is 10, and then 9 plus 4 is 13, but 13 modulo 12 is 1. Is this equal to something? Check on the first coset or the second coset. Okay, now let me put an asterisk. Notice that H1 and H4 are equal. H1 and H4 are equal. Should we continue, what happens? H5 with H5, okay, with H5, then we'll have, okay, plus 5 to every element of H. That will give 5, 8, okay, 11, and 5, 14, 2, correct? 2 modulo or 14 modulo 12 is 2. And this is exactly the same as, circle na lang tayo, as H2, yes? So we may stop here. Stop na tayo dito sa yan. Okay? Because the succeeding cosets, right, cosets will be equal to the previous or the first 3 anyway. Okay? Okay? And what else can you say? Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 contain the elements of G already. So this is how we form the right coset. How about the left coset? The left coset is simply, okay, let's have the left cosets here. Our G is the set of additive group, your Z sub 12, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And then our H is the subgroup of G, which is 0, 3, 6, and 9. How about the left cosets? Okay. Left cosets. So the left cosets are formed set of all elements HA, which is equal to A times H. Okay? Where A is an element of G and H is an element of H. Okay, baligtaran naman. So, 0H, 1H, these are the left cosets. A while ago, our right cosets are of the form H0, H1, H2. Now, you know very well that the additive group Z sub 12 is an abelian group because addition is commutative. So, what do you expect with the right and the left cosets? They will be equal. HO is equal to OH. Okay? So, OH is simply taking 0, add it to every 0, add it to every member of H. So, just the same, this one will give, okay, 0, 3, 6, and 9. What about 1H? 1H is simply adding 1 to every member of, okay, H. So, this one will give 1, 4, 7, 10. Okay, next, what will 2H be? 2H will be, okay, add 2 to every member of H. That will be 2, okay, 5, 8, and 11. And if we continue, okay, 3H, add 3 to each member of H, add 3 to each member of H. So we have 3, 6, 9, and 0, which is in fact our H. So ito yan, di ba? So we may stop here. Because anyway, all this, the first and the fourth are the same. So if we continue with 4H, then it gives us 1H, and then 5H will give us 2H. So these are the left cosets. So this is how we form cosets. Are there questions on forming the cosets? Okay, let's look into more examples. Okay, now we proceed to the next example. Find the left and the right cosets of the subgroup generated by delta in the set of permutations of 3 objects S sub 3. Okay, recall S sub 3. Remember that S sub 3 has the, okay, S sub 3 has the elements. I hope you still have your tables with you, but anyway, I have the table here. Alpha, beta, gamma, delta, phi, and rho. Okay, so I'd like you to find the left and the right cosets, okay, using this table and compare whether the left and the right cosets are equal. Okay, so in our previous example, we found out that the left cosets and the right cosets pareho. Si HO, so here we can compare, our HO is this, and our OH is just the same. So we found out that HO, okay, the right coset is equal to the left coset. Is this true with H1 and 1H? Tingnan natin. H1, 1H is 1, 1H is 1, 4, 7, 10. How about H1? 1, 4, 7, 10. Okay. Okay. Now, yung next kaya, pareho kaya ang left and right cosets? So the question here is, are the left and the right cosets equal? Is the set of permutations of n symbols an abelian group? Yung kanina, no problem because we are very sure that addition is commutative. How about here, number 2? Is it an abelian group? Now, let's see. Okay, find the left and the right cosets of delta. Okay, so in this case, this is our G. Our G is this group. The group consisting of the elements alpha, this is your set of permutations of 3 symbols, okay? Beta, gamma, delta, phi, and rho. This is our group. And the subgroup H is the group consisting of delta, phi, and alpha. Okay? Is this really a subgroup? You can check. Delta times, let's look into the table. Delta times phi is alpha, correct? Next, delta times delta is phi, okay? Phi times phi times phi is delta. So, it's close with respect to the operation. Next, I think we have checked on this before when we discussed subgroups. Okay, check on the properties. Okay, remember the properties of a group: closure, associativity, existence of an identity element, and inverse. So, the identity element is contained in the group. The identity element alpha is here. Okay, let's check on the inverse of delta. Inverse of delta is phi. Okay, nandito sa grupo. Inverse ni phi ay si delta. Okay. So, subgroup talaga ito, no doubt. Okay? So, that H whose elements are delta, phi, and alpha are really subgroups of G. What are we to find? The left and the right cosets and compare. Okay? Compare the left and the right cosets. Anyway, we only have 6 elements. Okay, so let's show our solution here. Kopyahin muna natin si table para meron tayong guide. Okay, so let me write down our G once again is the set. Okay, and our H is delta, phi, and alpha, which is the identity element. Here we have alpha, beta, gamma. Which one is next? Phi, delta, phi, and rho. Okay, let's insert natin yung table. Okay, para may guide tayo in coming up with the cosets. Okay, is this table visible? Okay, so we begin with the right cosets. Right cosets. Again, by definition, HA, where A is an arbitrary element of G. So the right cosets will be H alpha, H beta, H gamma, okay, H delta, H phi, and 1, 2, 3, 4, 5, and H rho. Okay. First, H alpha would be, okay, this one, H. This is your H. We only have 3 elements anyway. Delta times alpha. Yan na. Delta times alpha is delta. Remember that alpha is the identity element, so it does not change. Okay, so delta. Next, okay, phi times, again, next, phi times alpha, it will be phi. Okay, it does not change. Next, alpha times alpha is alpha. I hope you can follow. Next, okay, HB. Okay, next, delta times beta. Ito. Delta times beta. Okay, delta times beta. Delta times beta is gamma. Can you see that from the table? Delta times beta is gamma. Okay, so gamma. Next. Okay, next. Phi times beta. Phi times beta. So, phi times beta is, okay, rho. Okay, so rho. Next. Next. Alpha times beta will be beta. Next. How about H gamma? H gamma. So, delta times gamma. Delta times gamma. Yan, delta times gamma. Okay, get the intersection of the two. Delta times gamma is rho. Okay, so I'm going to write it here, rho. Next, okay, phi times gamma. Phi times gamma. Whereas phi times gamma is beta. Okay, next, alpha times gamma. Alpha times gamma is gamma. Okay. Next, HD. HD. Okay, not HD, H delta rather. Okay, delta times delta. Delta times delta. Delta times delta. Delta times delta is, yan, delta times delta is phi. Okay? Next, phi times delta. Phi times delta. Phi times delta is alpha. And finally, delta times alpha. Okay, delta times, alpha times delta, I should say, alpha times delta is delta. Let's write it properly to distinguish it from the rest. Okay. Next, H phi. Delta, bakit yun? Delta times phi. Delta times phi. Where is it? Delta times phi is, ulit, delta times phi is alpha. Okay? So, alpha. Next, phi times phi. Okay, phi times phi is delta. And finally, phi. Okay? Next. Okay? Delta times alpha. Sorry, delta times rho na pala tayo. This is the last. Delta times rho. Delta times rho is beta. Next. Okay, phi times rho. Phi times rho is gamma. And alpha times, yan, alpha times rho is rho. Okay, are there equal cosets? From here, I could mark out, this is in fact equal to your H. Okay, HB is equal to, look at the, okay, look at the elements. Ayan, the two are equal, yes? HB and H gamma. And even H delta equal to, okay, H delta din. H delta. And then H phi, okay, is also equal to H. Bakit D yun? Sorry. H delta, and that is also equal to H phi. How about this? H beta is equal to H gamma, and is also equal to H rho. Okay, so these are the right cosets. How about the left cosets? Okay. What about the left cosets? H beta, let me check, beta, alpha, and rho. H alpha, let me just check. Okay. How about the left cosets? Now we proceed to the left cosets. Okay? So baligtad naman. Alpha H, beta H, gamma H, delta H, phi H, and rho H. Okay, let's start with alpha H. So alpha multiplied to all of this will give the same set of elements because alpha is the identity element. So this one gives delta, phi, and alpha. Next, beta times, baligtad tayo ngayon. Okay? Sorry. So, beta times delta, beta times delta. Beta times delta is rho. So, I'm going to write here rho. Okay? Next, beta times phi. Beta times phi. Beta times phi is gamma. Okay? Gamma. Next, beta times alpha is beta itself because that's the identity element. Okay? Next, gamma H. Gamma H. So, gamma times delta. Gamma times delta is beta. Okay, so, beta. Next, gamma times phi. Gamma times phi is rho. Okay, so rho. And finally, gamma times alpha is gamma. Next, delta H. Okay, delta H. Delta times delta. Delta times delta is phi. Next, delta times phi. Okay, delta times phi is alpha. Okay, alpha. And lastly, delta times, okay, that will give delta because that's multiplying it to the identity element. Next, phi, okay, phi times H. So, phi, we begin with phi. Phi times delta. Phi times delta is alpha. Next, phi times phi. That's phi times phi is delta. And finally, okay, phi times alpha will be phi. Okay, next, rho times H. Okay, rho times delta. Okay, rho times delta is gamma. Rho times phi. This one next, rho times phi. Okay, rho times phi is beta. Okay, so beta. And finally, rho times k will be rho. Now, compare. What can you say about the left and the right cosets? Ito. Looking at, compare, I want you to compare H alpha and alpha H. Are they equal? Are they equal? Okay, delta phi, alpha, delta phi. Okay, so equal. Next, HB is equal to beta H. Are they equal? Okay, yes, the elements are exactly the same. Although the places may be different, but we are talking about sets. Gamma, rho, beta, gamma, rho. Okay, so equal to. So what can you say about the left and the right cosets? Okay, the left and the right cosets are equal. Okay, so in the first two examples, the right and the left cosets are equal. So let's proceed to the next. Okay, here is a theorem. Okay, a theorem about the partition of G. If H is a subgroup of G, then the right cosets of H in G form a partition of G. Okay, for example, going back to the first example, okay, these are the right cosets. So your G, okay, is simply H union H1 union H2. So we have three partitions, okay? H, H1, H2. If we put them all together, combine all of this, then this would make up the group whose elements are this, or the group G. We call this the partitions. Okay, in like manner, for the cosets, okay, of right cosets of S sub 3, saan yung S sub 3 natin? Okay, eto. The right cosets are, we only have two right cosets here because the rest are equal to the previous two. Yung dalawa, look at the two. Okay, the first two, okay, make up the set or the group G. Delta, phi, alpha, gamma, rho, and beta. So if we put together or we take the union of the two, then that gives G. So that has to do with the theorem. Okay, if H is a subgroup of G, then the right cosets of H in G form a partition of G. Next, what about a normal subgroup? Okay, normal subgroup by definition is a subgroup H of G such that GH is equal to HG. Again, a subgroup H of G is normal. How do we read this? If and only if. Okay? So this one here is read as if and only if. And how about this sign? For every. This is for every G, which is an element of G. If this is satisfied, GH is equal to HG, then H is a normal subgroup. Okay, is a normal subgroup of G. So, going back, let's answer this question now. Is H, whose elements are delta, alpha, and phi, a normal subgroup of S3? Okay, let's go back to our solution a while ago. What is the condition for being a normal subgroup? GH equals HG. So look at this. Okay, H alpha is equal to alpha H. H beta is equal to beta H. In like manner, H gamma is equal to gamma H. H delta is equal to delta H. H phi is equal to phi H. And H rho is equal to rho H. Okay, so what can you say about H? Is H a normal subgroup of S sub 3? Yes. Okay, so answer here is yes. So we're done with this, checking on the left and the right cosets. How about the previous examples that we had? Yung sa kay Z sub, ito. Is H also a normal subgroup? I'm referring to this H. Okay? Ito. Question, is H a normal subgroup of G, of this group? Okay, again, OH equals HO. 1H equals H1. Okay, since this is satisfied, then we can say that H here is a normal subgroup of G. Answer is yes. So you just have to check on the left and the right cosets. Okay? Now we proceed to the next. So that's how we form the left and the right cosets and checking whether H is a normal subgroup or not. Now let's have another example of finding the cosets and determining whether the given subgroup is a normal subgroup or not a normal subgroup of the given group. Let G be the cyclic group generated by 8 whose order is 12. Okay, so order of 12, 12 elements. Okay, generated by A. Remember how a cyclic group is generated? A times A squared times A cubed until A to the n, and that gives the identity element. So how shall I call this group? It's a cyclic group of order 12 generated by A. Okay, let me write that. It's a cyclic group or cyclic group of order 12 generated by A. So the generator of that cyclic group is A. We are to find the following. These are the left cosets. Okay, the first group are the left cosets and the second group are the right cosets. And we have identified here a subgroup. Okay, a subgroup of H or a subgroup of G, which is H consisting of A to the 4th, A to the 8th, A to the 12. Take note that A to the 12 is the identity element. Okay, so let's answer the following then. What is AH? Okay, what is AH? So we simply multiply A to each of these elements. Okay, we multiply A to each of the elements of H. So the first element would be A times A to the 4th will be A to the 5th. Yes? Next, A times A to the 8th will be A to the 9th power. And then A times A to the 12th is A to the 13th. But, okay, but modulo 12, that's A, correct? So, A. Kasi order 12 lang siya. Pag A raised to 13, babalik na siya to A raised to 1. Next, how about A squared H? So just the same, multiply each of these elements by A squared. A squared. So what will this be? A to the 6. This gives us A to the 6, A to the 10, and ulit. Okay? Times 2, times 2, times 2, or plus 2, sorry. Okay? Okay. And then A raised to 2. Next, we move on to the next. A to the 3rd H will give A to the 7, A to the 7, A to the 11, and A to the 4th power. I know, A to the 3rd, sorry. I'm sorry. A to the 3rd power. Next, A to the 4th H will be A to the 8th. Okay? And then A to the 12 and A to the 4th power. Okay, next, A to the 5th H will be A to the 10. Okay, A to the 10, A to the, yan, plus 5 lang dito. A to the 10, A squared. Then, A to the 6. Okay? Once more, from a to the, saan tayo? A to the 5th. Okay. A to the, sorry, wrong. Nag-skip ako. Let me erase it first. A to the 9 dapat. Okay, so this one should give a to the 9. Okay. A to the 1, a to the 1st power, and a to the 5th power. Okay, a to the 5th power. Next, a to the 6 will give us a raised to 10, then a squared, and then a raised to 6. A raised to 7h will be a raised to 11, a raised to the 3rd, a raised to 7. Okay, a raised to 8, h will be a to the 12th power, a to the 4th, a to the 8th. Next, a raised to 9h will give us a raised to 9, that will be a to the 13, yes, but that goes back to a, okay, and then a to the 5th power, a raised to 9. Next, a raised to 10h will be a squared, because that will be a raised to 14, but a raised to 14 is a squared, then a to the 6, then a to the 10 power. A raised to 11h will be a to the 3rd, a to the 7th, a to the 11th. And finally, a raised to 12. Okay, a raised to 12 will be a raised to 4, a raised to 8, and a raised to 12. Okay, so these are all the left cosets, so which are equal. So let's put a label on the, okay, equal left cosets. A, ito, is equal to, hanapin yung may a to the 5th. Ito, a to the, ayan. Yes? Okay, next. A squared h, hanapin yung may a to the 6, is equal to, we failed to underline also ito. Kasi pareho lang naman. Okay? AH and a to the 5th h, a to the 9th h, okay, are equal. Next, a cubed h and a to the 7th h and a to the 11th h. Next, this in fact is equal to your h. Yes, this is equal to the group, the subgroup rather. This is equal to h. Let's use a different color. A to the 4th h, okay, is equal to, yan, a to the 8th h. Ma'am, sa may a to the 4th, may a to the 12 naman dun. A to the 4th, saan yung a to the 4th? May a to the 12. Meron man, a to the 12. Anything else? Ato, a to the 12. Ayan, mga pareho. Okay. So now, okay? So now you can identify which left cosets are equal. So ito, babalik tayo sa nauna. Ito, repetitions na lang ito. Notice that all of this from a to the 5th hanggang dito ay repetitions lang siya. Okay? Nung naunang 4. Agree? Yes. Okay, how about the right cosets? Okay, mahaba-habang listahan ulit. How about the right cosets? HA would be, okay, a to the 5th, a to the 9th, okay, a to the 1st power. Next, we have HA squared will be a to the 6, a to the, okay, 10 and a squared. Next, a cubed will be a to the 7, a to the 11, and a cubed. Next, a to the 4th, a to the 8, a to the 12, and a to the 4th. Okay? Notice that the next or the succeeding cosets will be repetitions of the first 4. A to the 9, and then, okay, a to the first, kasi 13 na siya, or I don't have to put that exponent, so no need. So, a na lang. And then, a to the 5th. Next, a to the 6 will be, okay, a to the 10, a squared, a to the 6. Next, a to the 7, a to the 11, a cubed, and then a to the 7. Okay, a to the 8 will be a to the 12, okay, a to the 4th, and a to the 8. Then a to the 9 is a, okay, because that would be 13, and then a to the 5th, a raised to 9. A to the 10 is h, okay, because that will be 14 mod 12, 2. And then a to the 6, a raised to 10. A raised to 11 will be a cubed, a raised to 7, 7, okay, 7 plus 5, 11 rather. Okay, that would be 19, okay, minus 12, a7. Then a raised to 11, correct? And finally, a12 will be a to the 4th, a to the 8th, and a to the 12. Okay, so which are equal? Si HA ay equal kay HA to the 6? No. Ito, HA to the 5th. At equal din siya kay HA to the 9. Yes? Okay, so these are equal. Now, HA squared, circle na lang tayo. Lahat ng may a to the 6. Ito, pareho. Next, gamit tayo ng ibang color ulit. Ito, anong kapareho niya? Yung may a to the 7. A to the 7, there. Okay. And finally, ito. Check mark. Check mark. Ito, a to the 12. Ito. And this. Okay, so, ito, repetition na lang. Parang kanina din. So, the first 4, or should I say the succeeding 8, are repetitions of the previous 4, or the first 4. Okay. Now, we compare the left and the right cosets. Are they equal? Obviously, yes. HA and AH, A squared, okay. Okay. So, the H here is a normal subgroup. Okay? H is a normal subgroup of G. Are there questions here? On coming up with the cosets, right and left, now we proceed to the next theorem. Daming theorem. Theorem says, let H be a subgroup, okay? H be a subgroup of G if G, which is an element of the group, times H times the inverse of G is a subset of H for every G, which is an element of G, then H is a normal subgroup of G. Okay? So if it satisfies this condition, G times H, G inverse, G times H, G inverse, GH, this is the left coset, okay? GH or should I say, G and G inverse. These, what relationship exists between G and G inverse? They are inverses of each other. Okay, they are inverses of each other. So, if E here is the identity element A raised to 12, let me ask you then, what is the inverse of A? Okay, find, let me write down. Referring to or talking about the same group, the cyclic group of order 12 generated by A, and the subgroup H whose elements are A to the 4th, A to the 8th, A to the 12th. What is the inverse of A? Okay, remember by definition, A, by definition, when we speak of inverse, okay, inverse, A times its inverse, A times its inverse should be equal to the identity element E. Okay? So, going back to the group that we have just discussed, the group G, okay, cyclic group G, okay, find the inverse of the following. Okay, A inverse, what is it equal to? A squared inverse, what is it equal to? A cube inverse, what is it equal to? Now, go back to the definition. When we multiply A by its inverse, the answer should be the identity element E. In this case, the identity element, very clear, is A raised to 12. So, the question is, what shall I multiply to A in order to get A raised to 12? So, it's A raised to 11. And therefore, the inverse of A is A raised to 11. Okay? So, the inverse of A here is A raised to 11. Yung A squared, its inverse would be A to the 10. Okay? And the inverse of A cubed would be A to the 9. Why? Because A times A raised to 11 is equal to A raised to 12, which is the identity element. Okay? A squared times A to the 10 is equal to A raised to 12, which is the identity element. Remember, this is the definition of an inverse element. That which when multiplied, okay, that which when multiplied to a given element results to the identity element E. So that if I ask you now, okay, so, okay, how do we make use of the theorem to show that H is a normal subgroup of G? So, by the condition given in the theorem, G, H times G inverse is equal to, okay, with respect to the given in our previous problem, G and H, A, this, which is an element of G, times HA 11. Bakit 11? Again, 1 plus 11 is equal to 12. Okay? And it should be equal to H. Kapag yung sagot equal to H, then H is a normal subgroup of G. So, tingnan natin. HA 11 from our, okay, previous slide. Asan si HA 11? Sige, underline natin or encircle natin. Ito, kunin natin si HA 11. Okay, take note, HA 11, A cube, A to the 7, A to the 11. So, tingnan natin. Okay. Yan. A to the 3rd, A to the 7, A to the 11. Let's check on the condition. A Kung raised to 1, di dapat ito raised to 12. Okay? Erase muna natin. So, since, okay, the inverse of a raised to 1 is a raised to 11. Okay? May pakita natin yan kanina. The inverse of a is a raised to 11. The goal is to come up with a raised to 12 because that's the identity element. So, a, multiply it to each of the members of HA11. So, that would mean a raised to 1 times a cubed is a to the 4th. Next, a raised to 1 times a raised to 7 is a to the 8th. A raised to 1 times a raised to... Okay. Did we end up with h? Yes. Okay. Let's check it with the second. How about a squared times HA raised to 10? Again, y10. Okay, y10. 2 plus 10, 12. Okay? So, multiplying each term by... Okay, we get HA sub 10 muna. A10. HA10 from here. Kanina HA11 tayo, ito ang next natin. HA10. Take note, the elements are a squared, a to the 6, a to the 10. Sulat natin para hindi makalimutan. Okay? H, a raised to 10 has the elements a squared, a to the a squared, a to the 6, a to the 10. A to the 6, a to the 10. So that if we now find a squared, h, a to the 10, what will this give us? Okay, so we are simply to multiply a squared to each member of h8 raised to 10. What will that be? A squared times a squared, a to the 4th. A squared times a to the 6 is a to the 8. A squared times a to the 10 is a to the 12. Is this h? Yes. Okay, so here we ended up with h. Therefore, h is really a subgroup, okay? A normal subgroup of G. Okay, H is a normal. You can check on your own. I'd like you to check for a cube, H, a raised to 9. Will it be H also? Question mark. How about for a to the 4th? H, a to the 8th. Will it be H also? Okay? You check on your own na kasi mahaba masyado. Now, we move on to the next. We're done with this. Meron na tayong answers dyan. Okay? So, may we skip this one then? You can try other H. Okay? You can try other subgroups. Because we only have identified one subgroup here, what are other subgroups of G? Remember Lagrange Theorem? Here, the order is 12. So, ano yung mga posibleng subgroups ni G? Meron bang subgroup of order 4? Pwede ba? Is there a subgroup that will have an order of 4? Yes, because 4 divides 12. Meron ba? Ayan, ito. This is of order 3. Okay? Yung given natin, order 3. Okay, order of H is 3. But we can have a subgroup of G with 4 elements, with 2 elements, and with maybe 6 elements also. Okay? 6 elements divisible by, okay, should I say divisors of 12. Okay, divisors of 12. Now, we move on to the next. Okay na. So, we're done with normal. So, we're done with Lagrange Theorem. We're done with left and right cosets. We're done with normal subgroup. We proceed to the fourth concept this morning, quotient group modulo H. Okay, quotient group modulo H, but still referring to that same set, set G, or the cyclic group of order 12 generated by A and the subgroup H consisting of a to the 4th, a to the 8th, a to the 12. Okay? So we found out that HA is equal to AH, okay? And HA squared is equal to A squared H. HA cubed is equal to, nandun yun sa ating solution kanina. Pakita natin ulit. Ito. HA is equal to HA to the 5th. HA squared is equal to, okay. Ayan. AH, HA. Okay. Pareho. Okay. And this 4, okay, let me encircle the first 4 right cosets. Okay. If we take the union of these sets, take note we are talking of sets. If we take the union of these sets, then the set that would be generated, in fact, is G. Okay, the group G. So going back to that theorem, or to that concept of quotient group modulo H, okay, so we have established this already, that HA and AH are equal, HA squared and A squared H, HA cubed and AH squared, okay. If we take the union of the 4, then we end up with G. So, T here refers to the quotient group modulo HT, okay, which is G over H consists of, or is the quotient group modulo H, quotient group modulo H, consisting of H, okay, HA, HA squared, and HA cubed. And how is it written in symbols? T is equal to G over H. But take note that G over H, this is not division, okay? It's just a symbol. And to mean quotient group of G in H. And this one means, or is read as, the order of the quotient group. Or sometimes represented by absolute value of G over H, which refers to the index of G in H. Okay? So, T, saan galing itong T? H, HA, ito galing dun. Nakita natin kanina na ito equal to, may H pa tayo. Sobra pala. H, the given subgroup, A to the 4th, A to the 8th, and A to the 12. So, we need not include this na. Okay, so if we look into all of this, the first, the second, the third, and the fourth, they all comprise, okay, or their union makes up G. So, going back, the quotient group, therefore, of G modulo H, the quotient group modulo H of G is H, okay, HA, HA squared, and HA cubed. Next, how about if this is the question? Okay, we now consider the same cyclic group of order 12 generated by A. This time, H is A cubed, A to the 6, A to the 9, A to the 12. Okay, look at this. The order of G is 12, the order of H is 4. 12 or 4 divides 12. 4 divides 12. Now going back, the order of G is 12, the order of H is 3. Now if we get the quotient, 12 divided by 3 is equal to 4, which means that T will have an order of 4. Order, proper symbol. Okay, the proper symbol, order of T is equal to 4. True enough. How many elements are there for T? We have H, HA, HA squared, and HA cubed. 1, 2, 3, 4. Okay? 4 elements. 1, 2, 3, 4. Okay, there are 4 elements. Now, let's go back to the previous exercises or problems rather and check the quotient group modulo H. Saan yung kanina natin na Z sub? Si Z sub 6 kanina, yung example natin. Z sub 12. Okay, so for Z sub 12, our G is Z sub 12. Tingnan nga natin. Our G here is Z sub 12. Okay, our G, Z sub 12. What's the order of G? It's 12, yes? And our H here is this. Okay, the order of H is equal to 4. Okay, order of H is equal to 4. So if I divide, order of T will be equal to 12 over 4. But what is 12 over 4? 3. So that the quotient group T should consist of 3 elements. And what are they? Tingnan natin. Ayan, si H. H, H1, and H2. So H, H1, and H2. This is another example of a quotient group. Okay, so quotient group. Now, let's look into the previous. Sanong solution natin dito? Okay, how about here? Okay, so here, our G is this. What is the order of G? The order of G is 6. And our H, the order of H is 3. Diba? Checking on this, 1, 2, 3, 4, 5, 6. 1, 6. Order of H, 1, 2, 3. 3. So, T, what will be the order of T? The quotient group is order of G divided by the order of H. And what will that be? 6 divided by 3. Your quotient group will have an order of T. The quotient group will have 2 elements. Check na natin. Can you identify the quotient group here? Okay. Klaro. Ito ang quotient group. Okay? H alpha, H beta. Okay, so we have H alpha, H beta. So what is its order? 2. Correct? And that's it. Okay, so I hope quotient group and order or index or order. Okay? So let's go back to yan. Okay, order of T is G over H. Okay, so here our order of T is G over H. Let me write that. The order of T, simply order of G over order of H. Order of 12 over 3. So the order of T is equal to 4. True enough, how many elements are there for the quotient group? H, HA, HA squared, HA cubed, 4. 4. Okay? So, pag ganito naman. Okay? G, let G be the cyclic group, just the same. And H this time be A cubed, A to the 6, A to the 9, A to the 12. So, what do you expect? So, from here, if we apply the formula that we that we made use of a while ago, the order of T is equal to the order of G over the order of H. And that would mean order of T is equal to 12 divided by 4, may 3. So, T will have 3 elements. Yun ang hahanapin natin because the problem asks for finding the quotient group of modulo H or the T. How? Then, look for the right cosets. So, right cosets na lang tayo. Okay, HA, HA squared, our H. Okay, take note, our H, lakihan natin. Okay, so H is this time another subgroup, A cubed, A to the 6, A to the 9, A to the 12. So find the following: HA, HA squared, HA cubed. Alin kaya dyan ang mga... Okay, so let's answer HA muna. That will give A to the 4, A to the 7, A to the 10, and A. Babalik sa A kasi 13 na siya. Next, HA squared will be, okay, A to the 5th, A to the 8th, A to the 11, and A squared. Okay? If we continue with HA cubed, take note that this will give the first, kasi this will be A to the 6, A to the 9, A to the 12, and A to the 3rd. Take note that the first and this are pareho na sila, di ba? So we may not continue with it anymore. So these are the members of the quotient group na. So T will have the elements. Okay, so T will have the elements H, HA, and HA squared. Did you understand that? Okay, true enough, order of T is equal to 3. Okay, the order of T is equal to 3. 1, 2, 3. Okay? So by definition, now we've come to the definition of quotient group. If G is a group and H is a normal subgroup of G, then the group T of all cosets of G and H is called the group of all cosets. Okay, let me underscore the word coset. Group of all cosets in G in H is called the quotient group of G modulo H. Why did we not include? Bakit hindi na natin in-include si HA cube? Pareho na sila sa H, so no need. How about HA to the 4th? You'll end up with HA, so we don't have to include them. So we just have to write H, HA, and HA squared. Going back, okay, so the index of G and H is in fact the order, okay, order of T, where the order of T is given by G, order of G over order of H. So if I would ask you what is the inverse or index rather, ito. Order of G over order of H. So this is read as index of G modulo H, order. Okay, next we move on to the next theorem. If H is a normal subgroup of G, then for every pair of distinct right cosets of G and H, HA times HB is equal to HAB, where A is an element of HA and B is an element of HB. So by this theorem, we could complete the table. So from this rule, HA times HB is simply H times AB. So that if we have H times H, bakit na doble? HA ito dapat. Sorry. HA. Okay, HA times H is H. Okay, and then HA times HA will be from here. A times A. Si A lang multiply nyo. HA squared. Ito, from this rule. HA times HB is HAB. So, HA times HA will be HA squared. HA times HA squared will be HA cubed. Okay, next, HA times HA cubed will be HB A. Bumalik. Kasi hanggang HA lang tayo, A cube lang tayo. Yung H natin. Okay, so babalik kay H. Sorry, bakit HA yun? H lang siya. Okay? Because that would be A to the fourth na siya. Next, this will be, okay, H, A to the third, H, and then HA. This one will be H, then HA, and then HA squared. So that completes the table. Why? Pakita ko lang. HA squared times HA squared is simply H times A squared times A squared is HA to the fourth. But this is until HA to the third only. So this is equal to, okay, this one should be equal to H. Okay, so it gets back to H. And then if we have HA cubed times HA squared, that will be HA to the fifth, yes, but that is reduced to HA. Okay, so HA. Meron ba tayo? Yan, HA and HA squared. So compare it to the table here. Ayan na siya. Okay, so take note that these are the elements of our quotient group a while ago. Okay, these are the elements of our quotient group T. H, HA. Let's check. Is the quotient group a group also? Okay, is it a group? Although by the theorem, it says the cosets of G and H form a group with respect to multiplication of sets. So the operation is multiplication of sets. Is T closed with respect to multiplication? How do we check? From the K-list table, all entries are members of set T. Therefore, T is closed. Okay? So let me put a check mark here. It's closed with respect to the operation multiplication of sets. Again, how would you justify? Look at the table. All entries are found here. Next is it associative? Now you can check. Okay, check for associativity. So we can check for associativity. For instance, HA times HA squared times HA cubed. Is this equal to HA times HA squared times HA cubed? Okay, so HA times HA squared. Okay, HA squared times HA cubed is HA. Okay, so HA, is it equal to this? Okay, HA times HA squared, HA cubed times HA cubed. Okay, HA times HA, look at your table, is HA squared. Okay, so HA squared, is it equal to this? HA cubed, yan, HA cubed times HA cubed is HA squared. So, pareho. Okay, HA squared. So, is it associative? Yes. And you can check with some other, okay, or more cases rather. Is the identity, this should be number 3. Is there an identity element? Does it exist? Yes, and the identity element is in fact the group H. Okay? Oh, H is here. H times H, H. HA times HA, or HA times H is HA itself. So looking at this row and this column, that's after multiplying by H, the entries did not change. So which means the identity element of this group is H. How about inverse? Okay, what is H inverse? H inverse is H itself. How about H sub A? HA inverse. HA inverse, paano na yung hanapin ng inverse from the table? Hanapin mo sa identity element, anong minultiply kay HA to get H? HA cubed. So that's the inverse of HA. Next, how about the inverse of HA squared? Find along HA squared, find the identity element H. What was multiplied to HA squared to get H? It's HA squared. So, HA squared. And finally, HA cubed. What must be multiplied to HA cubed to get H? It's HA. So, that is the identity element HA. Okay. So, all properties of a group are satisfied. Closure property, check. Associativity, check. Existence of an identity element, check. And inverses of every element exists. Therefore, T here is a group. So that's by the theorem. But we were able to prove anyway that T is a group. So the theorem says the cosets of G and H form a group with respect to multiplication of sets. Now, the second to the last topic, homomorphism. Are you still okay? Kaya nyo pa? Pang second to the last na to. Okay, homomorphism. Let G and H be groups with respect to the operations circle and asterisk, respectively. So, here we have two groups, G and H. Take note that they are distinct, magkaiba. Distinct groups with distinct operations, and the operations are as follows, circle and G. Circle and asterisk rather, respectively. A homomorphism of G into H implies mapping. Okay? Is a mapping phi in G, so G is mapped to H, such that for every AB, which is an element of G, okay, element of the group AB, then phi of A circle B, phi of A circle B is equal to phi of A asterisk phi of B. So, note, here we have two distinct groups. Okay? And the operations therefore defined are different. Dalawang magkaibang grupo. Gagawan natin ng mapping. Okay, so tingnan natin yung example. Huwag na tayong lalayo sa cyclic group kasi yun ang pinaka-simple. So ito, we consider G as a cyclic group, this time of order 8. Kanina yung examples natin, order 12. This time, cyclic group of order 8. So, hanggang A to the 8. Ang identity element is A to the 8. Cyclic group of order 8 generated by A. So, this is the group. And a subgroup, okay, of another group, let's say H. H, whose elements are 3, 6, 9, 0. Saan galing ito? Sa Z sub 12. Addition modulo 12. Subgroup niya si H. Now, we will make a mapping of G to H. Elements of G are A until 8. Okay, A until A to the 8 rather. And the elements of H are 3, 6, 9, 0, 3, 6, 9, 0. So, we made a mapping. These are elements of G to elements of H. So, it's a mapping from elements of G to elements of H. And we have, should I say, called that mapping as phi. Phi maps G to H. A is mapped to 3, A squared mapped to 6, A cubed mapped to 9, and so on and so forth. Okay, now, going back to the definition. When is it a homomorphism? It's a homomorphism when this is satisfied. Okay, phi, hindi siya nakikita pag yellow, red na lang. phi of A circle B is equal to phi of A star phi of B. Okay, so let's copy. Ito yon. Okay, so phi of A circle B should be equal to phi of A star phi of B. Take note that circle and star are distinct operations. Circle is defined in G and star is the operation in H. So that if we have if we identify two elements of G, going back to the definition again, okay, such that, eto ha, let me underscore, such that for every A, B, two elements, okay, of G, then it has to satisfy this. So, let's identify two elements of G. Let's say A squared and A to the third. So, the mapping or phi of A circle B, A and B refers to two values in G which we have identified to be A squared and A to the third. And the operation for G is multiplication, diba? Multiplication, kaya ito. Equals. Okay? This is supposed to be with a question mark because we are checking whether it's a homomorphism or not. Okay? So, phi of A squared times A cubed, is it equal to phi of A squared star phi of A cubed? So, let's see. Okay, let's simplify this first. A squared times A cubed is A to the fifth. Kaya, phi of A to the fifth. Is it equal to? Okay, next. Phi of A squared, but what is star? What is the operation in Z sub 12? In H, ito, very particular tayo. Addition modulo 12. So, instead of star now, I'm going to make use of the operation in H, which is addition modulo 12. Okay? Phi of A cubed. Now, let's simplify. What do we mean by this? Phi of alpha. Phi of A to the fifth power. Go back to the mapping. Okay? Phi of A to the fifth power. Let me erase this now. This is our function, or this is the mapping. A to the fifth is mapped to A to the fifth power is mapped to 3. So which means phi of A to the fifth power is equal to 3. If I would ask you what is phi of A squared, what will that be? It would be 6. What is phi of A then? What is it equal to? It's equal to 3. So let's go back. Phi of A to the fifth from our mapping is 3. Is it equal to this? Okay, let me use blue ink. What is phi of A squared? Okay, phi of A squared is 6. There we have 6. Okay, plus, what is phi of A cubed? Phi of A cubed is 9, kaya plus 9. So, alam nyo na kung saan galing itong mga numbers na to. 6 and 9. Now, let's continue. Now, 6 plus 9 modulo 12 is 15 modulo 12. But 15 modulo 12 is 3. 3 is equal to 3. And therefore, this is an example of a homomorphism. Okay? Now, let's check with other pair. How about phi of A cube circle, bakit B? Sorry. Circle A to the fifth. Will this be equal to circle of A cube? Phi of A to the fifth, will they be equal? Check natin. Okay, so phi of the operation in G is multiplication. So this is the same as a to the 8. Okay, is this equal to this? Phi of a to the third. What's the operation in H is addition modulo 12. Phi of 5. So let's simplify now. Go back to our mapping. What is phi of 8? Yun, 0. Okay, so 0. 0 din kaya yung other side. Tingnan natin. What is phi of 3? So let's 9. Okay, so 9 plus phi of 5. 3. Okay, plus 3. Oh, obviously, 0 is equal to 0. Okay, 0 is equal to 0. And that's a homomorphism. Okay? So, for isomorphism, this is what you have to remember. Ito lang naman. For isomorphism, if the mapping is 1 to 1. If the mapping is 1 to 1. So, in this case, the mapping is 1 to 1. 1 to 1? No, it's not 1 to 1 because we have here, merong na doble. Okay? 3, 3, so hindi siya 1 to 1. Kung pag 1 to 1 ang mapping, it's an isomorphism. Okay? Every cyclic group of order n is isomorphic to Z sub n. Next. Last for this morning. Kaya nyo pa? What time is it? 12:16. Kaya pa ba? Last na to, rings. Sige, kaya pa or stop na? Balikan na lang. Parang wala nang nagre-respond. Kakayanin daw nila. Sige, kakayanin o stop na? Nasa sa inyo. Yung iba, may data pa ba kayo? Wala na. Wala na. Sige, pang-last naman na. Sige, tapusin na natin. Rings. Rings. So, here is another algebraic structure called rings. Ang difference ng ring sa groups, ito, dalawang operations. Sa groups, isang operation lang. Tinignan natin ano. So, a ring is defined as a set R of elements on which are defined two binary operations. So, that's the difference. Here we have two binary operations, star and circle, or asterisk and circle. These are just representations. Pwedeng addition, multiplication. Okay, addition, multiplication. So, representation lang yan. Star and circle satisfying the following conditions. For a group, how many conditions must be satisfied? How many properties must be satisfied? 4 lang. Very easy sa group. Closure, associativity, identity, and inverse. But for rings, doblehin nyo. 8. Okay? So, 8 properties should be satisfied. Okay, number 1. R, the set R is closed with respect to the first operation. Take note that there are two binary operations defined on R. Otherwise, kung isa lang ang operation defined on that set, automatically, hindi na siya ring. Okay? So, condition number 1, it should be closed with respect to the first operation. Next, the first operation must be commutative. Next, the first operation must be associative. Next, there should be an identity element with respect to the first operation such that A star, the identity element, is equal to A. Then, number 5, every element of R should have an inverse with respect to the first operation. So the first 5 properties with regard to or has to do with the first operation. What properties must be satisfied? Closure, commutativity, associativity, existence of identity, and inverse. Yung unang 5 refer to the first operation. The succeeding 3, sabi ko 8, is pertaining to the second operation. R is clause with respect to the second operation. The second operation is associative. And finally, the first or the second operation is left and right distributive over the first operation. So how many properties should we check in order to say that a group, or should I say a system or an algebraic structure is a ring or not? 8 properties. So let's decide. Okay, so I think this is the second to the last assignment na yun. Third to the last slide. Which of the following are rings? Yung set of integers. Okay, is it a ring? Okay, so your set of integers, we have 2 operations defined on it. Addition and multiplication. Itong circle here, multiplication. So, it's easy when we speak about the set of real numbers because the properties are already established. We know that the set of real numbers is close with respect to addition. It is commutative. Addition is commutative. Okay? Addition is associative. Okay? There is an identity element and that is 0. And there is an inverse of every element, the negative of the number. Okay, so the first 5 properties are satisfied by both. Okay, para mabilisan tayo. Now, the succeeding properties, number 6, okay, is the set of z integers close with respect to multiplication. Yes, when you multiply any 2 integers, the result is an integer. So, number 6, check. Okay, number 7, associative ba ang multiplication? Check. Associative property of the set of real numbers. And left and right hand is, di ba may property tayo na DPMA? So, check na yon. Which means that the first 2 are rings. Okay? So, this one is a ring and the second is also a ring. The question is, yung Z sub M kaya? Z sub M, ring kaya yan? Yung set of integers modulo M? Okay, ring din yan. Sure? Okay, so closure with respect to addition, yes. Okay, commutativity, 3 plus 2 modulo 5, 2 plus 3 modulo 5, pareho ba? Yes. So, commutativity, associativity, we have checked on that in our previous lessons. And then, inverse, yes, may inverse, or my identity element, which is 0, and inverse of every element exists. And then, number 6, closure with respect to multiplication, yes. If you could recall, I asked you to construct Cayley's table before for Z sub M, okay? And then, associativity, check. And left and right distributivity, check. Okay, left and right distributivity. If you forgot about left and right distributivity, then we can recall. Let's say si Z sub 5 na lang. Specific case tayo. Although we can prove in general. So, left and right distributivity. Ano ba yung left hand and right hand distributivity? Yung DPMA nyo, dalawang klase yan eh. Left and right hand distributivity. Yung A times B plus K modulo 5. C is equal to A times B modulo M or modulo 5 plus A times C. Bakit modulo 5 pa rin tayo? Let's take Okay. So, ito yung left-hand distributivity nyo. Wag muna tayo dyan. Wag muna tayo mag-specific. Let me erase this first. Your left and right-hand distributivity. Left. Ito na lang. Is A. That's left distributivity. And yan, left and right hand distributivity. So, yung right hand, okay, star tayo, circle. Because we are talking of the operation star and circle. So, yung baligtad niya, that would be A, or baligtad. Baligtad tayo because our operation is multiplication and addition. Si multiplication dito, so that one is A star B, circle A star C. Yan ang checking for left-hand distributivity. Okay, left-hand distributivity. Okay, so we can check on that. If we have Z sub 5, whose elements are 0. Okay. So if we have 3 star B circle YB, 4, ano na lang, 4 circle 2, or in terms of the operations defined on Z sub 5, we have addition modulo 5 and multiplication modulo 5. So ito will be 3 times, okay, modulo 5 of 4 plus 2 modulo 5. Ito yung left-hand distributivity. Checking on it and then simplifying it, this will give us 3 times 4 modulo 5 plus modulo 5 of 3 times 2 modulo 5. This is how to check for left-hand distributivity. Although we're using specific cases, we can make use of general terms. Okay, 3 times, okay, and simplify. 4 plus 2 modulo 5 is 1. Okay, so we don't have to enclose it in a parenthesis. Is equal to, is it equal to pala? Because we're still checking. 3 times 4 modulo 5, that's 12 modulo 5 is 2, plus modulo 5, 3 times 2, 6, 1. Okay, ay bakit naging ganon? Three times 4, okay, 4 plus 2, 6 modulo 1, 3. Okay, tama naman. Okay, 3 is equal to 3. Okay, 3 is equal to 3. So this is checking on left-hand distributivity. So for sure, this is a ring. Okay, this is also a ring. How about number 4? What can you say about number 4? Set of rotations. Okay, remember S, symmetries of a square, and RO, R1, R2, R3 are rotations, counterclockwise rotations about, okay, of a square, symmetries of a square. So, for number 4, what can you say? Is it a ring? Is number 4 a ring? Number 4 is not a ring. Why? Why? Number 4 is not a ring because there is only one operation defined on it. Okay, wala na iba. Rotation lang. So, it's not a ring. In like manner, number 5, okay, Z and the operation star. O, isa lang mga operation ng given. Operation star lang. Yun nga lang, the definition of star is A star B is equal to the first number plus twice the product of the first number and the second number. What do we mean by this A star B? Okay, A star B is defined as A plus twice AB. So, kung meron kang 3 star 4, what will that be? A, the first number, plus 2 times the first number and the second number. Okay, and that is equal to 3 plus, okay, 24, which is 27. This is not a ring, okay? Not a ring because there is only one operation defined on it. And number 6, okay, set of all, okay, numbers 5m such that m is an element of Z or multiples of 5. Ring kaya siya, and there are two operations defined on it, addition and multiplication. So, pang last na. Sagutan na lang natin itong number 5, number 6, so that you will have a basis in answering number 7 because I gave this in your assignment. Okay, so let's show whether or not ito na talaga ang last. 5m such that m is an element of Z, okay, with respect to the operations addition and multiplication. Show whether is a ring. Okay, so let's prove. Okay, show the proof. Okay, number 1 is S closed with respect to the first operation, addition, which means when we add any two multiples of 5, will the result be a multiple of 5? Like 5 plus 10, 15. 15 plus 20, 35 is a multiple of 5. But in general, how do we prove that? Okay, let's say, okay, 5m sub 1 be the first element of S plus 5m sub 2, okay, where m here, it's anyway very clear in the definition, m is an element of Z, okay. Will this be equal to 5m? So we have to show that the sum of any two multiples of 5 is a multiple of 5. Or in this form, ganito din ang forma niya, 5m. So that is our target. Okay? When we add any two multiples of the set, the result will be of the form 5m. Forma din niya 5 times m, where m is an integer. So here, our m1 and m2 are elements of Z. Okay, so is there anything we could do with the number 1 so that the result, we have to show that it is also 5 times an integer? Okay, by factoring out, okay, we could factor out 5, yes? So giving us 5 times m1 plus m2. Reason? By factoring. Okay? Now, take note that m1 and m2 are elements of Z. And when we add m1 and m2, the result is also an element of Z. By, okay, how shall we reason out? 5, okay, 5m by closure property of addition with respect to the set of integers. Okay, so answer here, yes. It's close with respect. We were able to show that the sum of any two multiples of 5 is also a multiple of 5. 5m. Number 2. Okay, number 2. Is addition commutative? Okay, so here we have to show that again, if 5m1 and 5m2 are members of the set, 5m1 plus 5m2, we have to show that it is equal to 5m2 plus 5m1. So how shall we do that? Do some manipulations, algebraic manipulation. 5 times m1 plus m2. Again, reason here by factoring. Next, I could interchange m1 and m2's places. I could write this as m2 plus m1. What's the reason? By commutativity of in Z. Okay, in the set of integers, we can change the places of numbers to be added, right? Next, finally, by distributive property, by dPMA, we'll have 5m2 plus 5m1. So we were able to show commutativity. Okay, next, number 3. Okay, number 3. How about associativity? The question here is, let me check the time. Oh, 12:36. I think I leave associativity na. It's somewhat similar to the previous. Maybe proceed to, let's proceed to the next property, which is number 3 is associative. Okay, I leave that to you. Number 4, identity element. Okay, is there an identity element with respect to addition? By identity element, we mean A plus the identity element should be equal to A. So, 5m plus E is equal to 5m. What should that be? E is equal to 0. And take note that we could write this. Is this a member of the set? Yes, because I could write 0 as 5 times 0. Does it still take the form 5m? Yes, still takes the form 5m, where m is equal to 0. Okay? And this is a member of your Z, set of integers. So this is the identity element. Next, number 5, inverses. Number 5, inverses. Are there inverses? By definition, A, okay, plus the inverse should be equal to the identity element. So in this case, A plus A inverse is equal to 0. That's what we found out from here. Okay, so 5m plus A inverse is equal to 0. Then what is A inverse? Is equal to negative 5m. And take note that I could write this as 5 times negative m, and negative m still a member of the set of integers. Okay? Negative 5m. Number 6 is S closed with respect to the next operation, multiplication. So just the same, 5m1 times 5m2, will it be equal to, okay, 5m1 times 5m2 will it be equal to 5m? Yung forma nung members ng set, 5m. Okay, so from here, we could group together m1 times 5 times m2, and by commutativity of ordinary multiplication or of the set of integers, then 5 m1 times m2, 5, okay, m, okay, 5m. 5m, your reason here is, okay, ito, this is simply by factoring or grouping or associativity. Associativity of in Z. Okay, this one is also by closure property of Z with respect to multiplication. What do we mean by that? That when we multiply integers, the result is an integer. Kaya 5m. And then number, okay, 7. What's property number 7 for a ring? Associative, closed. Hindi. Na-check na natin ang ito. Na-check natin ang closure with respect to addition, commutativity, associativity, 4, 5, closure, associative. Associative, and then left and right hand distributive na. Okay, so yung last na lang, left and right hand distributive. I leave number 7, may we have number 8. Okay, left hand distributivity is, okay, we have to show that, okay, A times the quantity B plus C is equal to the quantity AB plus, okay, BC. AC, sorry. Okay, AB plus AC. Okay, dapat ganyan. Okay, but here we have 5m1 times 5m2 plus 5m3 should be equal to, is it equal to 5m1 times 5m2, okay, plus 5m1 times 5m3. Okay, how will this, this is by substitution. So I prefer working on this side and bring it to, when you prove, you could work on both sides or work on one side and bring it to a form equivalent to the other side. So I prefer working on this. So by DPMA, by distributive property of multiplication over addition, ito siya. Okay? Then 5m1 times, by factoring it out, 5 factor out, m2 plus m3. And then, I will multiply 5 with 5m1. So I will have 25 m1 times m2 plus m3. Okay, by multiplication yan. And then by DPMA in Z, referring to the set of integers, okay, I could multiply this with 25 m1 times m2 plus 25 m1 times m3. Okay? And then by factoring out, I could factor this out into 5, 5. Okay? And by applying commutative property, that's 5 times 5 m1 times m2 plus 5 times 5 m1 times m3. Then 5 m1 times 5 m2 plus 5 m1 times 5 m2. Okay? And this is by factoring. So that's it. Are they equal now? 5m3 rather. So this is what I did. I simplified, or should I say I worked on one side of the equation and brought it to a form equivalent to this. So 5m1 times 5m2 is exactly equal to this, and 5m1 times 5m3 is exactly equal to this one. Okay? And so that's it. So I was able to prove the answer here is yes, it's a ring. Okay, so this one is a ring. So we were able to prove that the set S, whose form is 5m, where m is an integer, or in other words, we say it's the set of multiples of 5 with respect to the operation addition and multiplication, is a ring. So expect that even numbers with respect to addition and multiplication are rings also. Okay? So that's it.